Characteristics of quadratic function. I'm going to describe characteristics of parent quadratic function, which is f of x equals to x squared. Well, most of you in grade 10, 11 and 12, you're very familiar with quadratic functions, so you can pause the video now and write down all the characteristics you know about, and then watch the video, which is going to be a review for you, right? Now let's start with the review on quadratic function. And I'm considering parent function, as I said, f of x equals to x squared. Now, key points. We have learned many techniques of sketching quadratic function. Let's see how to sketch fx equals to x squared. Now, I'll consider a few key points to sketch this function, starting with origin, which is on the function. If x is 0, f of x is also 0, right? So let me write down 0 to start with as one of the key points on the given function, which is f of x equals to x squared. So if x is 0, 0 squared is 0, so f of x, the value of the function at x equals 0 is also 0, right? So we get 0. That means here we are writing x values, and then we are writing f of x values, which is x squared. So let me just squeeze in x squared here. Okay. How about when x is 1? 1 squared is 1, x is 2, 2 squared is 4, right? And then I'll just take 5 points. So if I have x as minus 1, then what? If x is minus 1 squared is 1 plus, and minus 2 squared is 4 plus. As you can see from here, there is some symmetry, correct? F of x and f of minus x have the same values, right? Which is f of x. Do you see that? That's the symmetry for the given function. So if you have any value here, for example, if I put a value 10, for example, here, in that case, 10 square is 100, and minus 10 square will also be 100. So that's what I'm trying to say here, that there is kind of a symmetry which you can appreciate as you fill in some values. So the key points for us will be 0, minus 1, minus 2, 1 and 2, right? So these are key points, and if the value is very large, we see that the f of x is also very large but positive, right? So for both negatively large values, right, we have positively large values. That's what we observe from these values, correct? So the key points are minus 2, minus 1, 0, 1 and 2, plus any value which is negatively large will give us positively large value, and a value which is positively large will give us positively large value, right? So the function increases on both the sides. Now let's plot these values and see how the graph looks like. We know it's kind of a parabola, right? 0, 0, so that's first point. 1, 1, that's the second point. 1, 1. 2, 4, so at 2 we have value 4. Similarly on the left side we have minus 1, 1, minus 2, 4, right? If you continue this, you can make your parabola. Now to draw the graph of a parabola, I would also like to share with you another important criteria, and that is, we know it's kind of a step in which we can move, and the step is 1, 3, 5, 7, like this. So these are the steps in which a parabola moves, right? So let's check what do we mean by these steps. Normally what we do when we sketch a parabola or a quadratic function, we locate the vertex. In this case the vertex is at 0, 0, right? And then if you move 1 unit to the right, you have a step of 1, so that is 1. Do you see that? If you move the next unit to the right, we have step of 3, that is 3, 1, 3, right? Now if I move 1 more unit, the step should be 5, right? So that means it should be 1, 2, 3, 4 and 5. So that is my next point. Do you understand? So that is how you can get more and more points and then plot your graph. I hope that makes things very clear. So you get the next point moving in these steps. So if you join them, let me just join them with a smooth curve, which looks like a parabola, right? So like this, we can join them, right? And as you have seen that there is a symmetry, and this symmetry is called even symmetry. So if you have a point here, there will be a corresponding point on the other side, right? So that means for -3, you should have a point at 9, right? Yes, it should be. -3 square is +9. So you can just join them like this. So you have a curve which looks like a parabola. So we say it's a graph of which looks like a parabola. Opening up, which opens up. Do you see that? So remember one thing, to sketch a parabola, fx equals to x squared, you can also use the strategy of starting with the vertex and going with the steps of 1, 3, 5, 7 on both sides, since the function is also symmetry, right? So that is what I wanted to bring to your notice. Now let's write down domain and range. There is no restriction on domain, so domain is x belongs to real numbers. You can write any value of x. Range is restricted. It's only opening upwards, right? Where 0 is included. So we say y belongs to real numbers where y is greater than or equal to 0. How about quadrants? As you can see, it is in quadrant 2 and in quadrant 1. Right? So we always see the graph from left to right, and therefore I've written 2 first. So it moves from 2 to 1. Symmetry, as I said, it is even. Even symmetry. So what is peculiar about even symmetry? That is that f of minus x is equals to f of x. If I write f of minus 3, then it should be same as f of 3, which is 9. Do you see that? This is what we got, that point, right? So we have this point which is 3 and 9, and if I write minus 3, then also we get 9. So that is what we mean. So f of minus x equals to f of x. Okay? X and y intercepts. X intercept is that x equals to 0, and y intercept is that y equals to 0. So we say that the origin is on the curve, right? Which is 0, 0, right? Increasing and decreasing intervals. Can you tell me what is the interval of increasing and what is the interval of decreasing? You can see that the function increases from 0 to infinity, correct? So increasing interval is from 0 to infinity, and decreasing is from minus infinity to 0. How about end behavior? End behavior really means if x values are very large, negative or positive, what happens to y values? In this case, we see if x value is very large, negative, or if x value is very large, positive, then what do we see? Y value is always positive. Positively large, right? So it opens in one direction, right? That is how it is. Now let's look into rate of change. Rate of change for a parabola is very characteristic. Now if you see the vertex, and if I want to draw a tangent at vertex, it will be a horizontal line, right? So let me use a different ink here. So that becomes 0. Do you see that? If you move to the right side, and if I draw a tangent at any point, it is having with positive slope. On the left side, the slope is negative. Do you see that? More you go towards the left, steeper it becomes, more negative. More you go towards right, steeper it becomes, but more positive. Do you see that? So that is how the rate of change really changes. Do you see? So can you write down how does rate of change changes for a quadratic function? Well, you'll notice that is extremely large negative value, right? So it becomes from very, very negative value to very, very positive value. Do you see that? So what's 0 in between, right? So basically it is always increasing. Always increasing from a negatively large value to 0 to positively large value. So rate of change is always increasing. So that is kind of very typical of a quadratic function. Okay. Now let's get back to 5 important characteristics which will make quadratic function different from other functions. So let's start from the last one, which is rate of change, which I think is very characteristic, always increasing. Always increasing, like that of a straight line. Do you see that? Now that's kind of very important. Second, which I think is very important, is that it's only in quadrants 2 and 1 and is symmetric about y-axis, and that is why we say even symmetry, right? So even symmetry means either we can write algebraically f of minus x equals to f of x, or we can say symmetric about y-axis, right? So these are very typical of a parabola. Second, you see it's a smooth curve, right? Like any polynomial, right? So parabola is a smooth curve. So there are no vertexes or corners or cusp in this curve. It's a continuous smooth curve. So, and it goes through origin, right? So it has same x and y intercepts which are there. So this is the common characteristics for most of our parent functions which we are discussing in this playlist. I hope that helps you to understand quadratic functions, right? And to compare them with other functions like absolute function, square root function, and so on, right? I'd like you to answer some of the questions which I have in the description part, and then move on to understand the characteristics of other parent functions. Thank you and all the best.